Okay, so remember, let us see how do we handle these trigonometric proofs. But please don't forget to subscribe to the channel. Now, to handle these trigonometric proofs, we say we are going to divide the proof into two sides, the left-hand side and then the right-hand side. So we prove that the left-hand side is always equal to the right-hand side. So if I'm going to show that if A, B, and C are angles of a triangle, if they're angles of a triangle, it means they add up to 180 degrees. Then this is this. I'm going to handle this, reply this as exercise. So here what we use, whenever we have small a, small b, small c, you think about sine rule. So sine rule states like this, meaning that if I make a the subject, start a over sine a, if I do this, when I multiply this here, that's why we will get this. Then b, the same thing, and c. We know that also sine of 180 minus theta is equal to sine of theta. So the sine of 180 minus any angle is equal to sine of that angle. Then this is how we use the double angle of sine. What you need to know that if this angle is 2, or if this one is half the angle there. So let us see, this is our left-hand side, and this is our right-hand side. So I want to say that my left-hand side is equal to this right-hand side. So from sine rule, I'm going to substitute these things in there. So this will be now A is sine C. Now it's that sine 2r is going, 2r is going to be common. So if I divide through by that, I have now plus sine C. So dividing through by 2r because 2r is common. Now from here, we use factor formula. But now, because we are going to use factor formula, you see that always sine A, sine, we are going to add sine A plus B. So you are not going to be adding it. So now your task is to remove the C. How do you remove that C? You use the idea that, you know that A plus B plus C, all of them are added up to 180. Why? Because they are angles of a triangle, and angles of a triangle add up to 180 degrees. So we know we want to remove this sign. Why? Because when I apply factor, I'm going to be having 100A plus B. So I don't want C. So from here, I said our C will be 180 minus now the whole of this A plus B into this sine equals sides. So that from here, my sine C will be applying this property here, that sine of 180 minus an angle is equal to sine of this angle. So from there, allow me to say this is sine A plus B using this property. So now when I apply here factor formula, I'm going to be adding sine, I'm going to be adding, because I'm adding sine I have, so 2 sine of this angle, then by 2, then cos, when I subtract those two angles, then minus sine C, our sine C is there, and sine of A plus B. The whole over, this will be, I add the angles, then by 2, over 2, then plus sine C, which is sine A plus B. Now, it's like this one, I have applied factor formula, now I'm having this, but now I need to remove this using the idea of double angles. What does double angle say? If I have sine 2 theta, it means that always the angle here is half the angle here. Meaning that if I have now, I can express this as this how? As half angle. So from here, you can start always now my sine of A plus B will be, now using double angles, going to be 2 sine. Now this angle is always, the angle there are always half the angle here. So this angle, then I divide it by 2. Then also cos of a plus b over 2. The angles are the same when you look at also here. But if this is 2, this is a half of 2. So if this is just a theta, this will be a half of theta. So what I'm doing, this is just a plus b, then this is going to be a plus b over 2. So now, where is this? I'm going to put it here. So now this will be equal to 2, now 2 sine of a plus b over 2, then minus. Now where is this? I'm going to put the other angle. This is a plus b over 2, then cos of a plus b over 2. I'm putting there, I'm applying the double angle sine. Then here, I'm going to be having 2, then cos, then I'm putting the same thing. Where is this? I put that. Here, you can divide by now, we see that there's something common. What is common? We see that this is common here, and this is common here. So if I press it out, so you see that I can factorize out this with ease. Or you say this is common here, it's common here, it's common here, it's common here, you can reduce it. So we'll be adding the remainder there will be now, okay, 2 sine a plus b over 2 is common. Inside here I'm going to be having now cos over 2, then minus over, the same thing is common in here, so 2 so here I have cos a minus b over 2, then plus here. So you see that now, this will reduce with that. So now here, I'm going to apply factor formula. So it's like here, I'm subtracting cos and cos. So from there, my left-hand side will be apply factor formula. So shall add these angles and we divide them by 2. So I'll add now a minus b plus a plus b. This is a plus b. So that I'm going to be adding now, because I'm subtracting cos and cos, this will be negative 2. Now sine, we add those angles, we add this angle and this angle. So we have over 2, then plus this angle. Then after, we divide them by 2. Then sine of the same angle, if we are subtracting them. Then the same thing down, we shall be adding. Now here is that we are adding, so it's going to be cos cos. So we have now 2 cos of the same thing. We are adding this angle and this then by 2. Then we start to back to them. Then we are dividing by 2. Don't forget that we are dividing the whole by 2. So let us see what we get after simplifying. So we have negative 2. So here, instead we are going to be adding a. When it is the same way, we are going to be adding 2a, which we divide by 2 we get a. But this we divide by 2. So there we have sine a over 2. Then here, so we are going to be adding minus minus a, we will go, then minus minus b, divide by 2, that will be negative b, divide by this, so we have now sine negative b over 2. Then down, we have 2, then here, so we shall be having cos of a over b, a over 2 is going to survive, Then here instead we have this minus this. It's going to give us cos of negative b over 2. But you know that in trig, always sine of negative theta, the same as negative sine of theta, and cos of a negative theta, the same as cos of a positive theta. So meaning that now when this negative comes out, it's going to cancel that. So this 2 will go. So this negative and this negative are going to vanish. So this is going to be now sine a over 2, then sine b over 2. I'll remove this negative out using this property. So this negative cancel with this negative to give you a positive. Then over, now we have cos a over 2. Then cos this over negative, the same as the positive, b over 2. From there, remember to see sine a over cos a gives us a tan a over 2. Then sine b over 2 over cos b over 2 will give us a tan b over 2. And so this one is equal to our right hand side. I think you can see numbers that we have got that proof. Don't forget to subscribe to the channel. Wait for more. I wish you the best.